Hey, and good morning from a fairly cold and wet Walla Walla. But it's supposed to warm up in the next few days, and that'll be great. I got a bunch of stuff I gotta get done outside. But meanwhile, inside, I wanted to talk about it's been brought up several times, and I'm kind of flattered in a way over it, but asked about me having an apprentice. Well, that is absolutely not possible here because I'll tell you what, some folks came in here and they were shocked. You can take a GoPro camera and make things look pretty big. Yeah, small things look big, but this garage is 9 feet across and 19 feet long. It's smaller than it looks on this camera. And it's impossible to have another person in here working. It's not possible. Now, also, when I had a shop with lots more room, a commercial shop, I couldn't have an apprentice there either because of the regulations of having an employee. And then there's the other thing about having an apprentice that's not said. And it's not really talked about around here. We had a very good program out at the community college, and they closed it. And it made a lot of people mad, and they're closing a lot of other mechanical things out there too. The base reason they closed that machine program, and the welding too, is people that went through it weren't getting jobs. And that's the bottom line. Now, I don't I don't come to you to learn machining because see we had a good base here, but I do have some ideas on how to get yourself into a better position to be able to make things to learn that. Okay, I'm going to go over to the other side of the shop. Sit down. Back in the 70s, working in machine shops was extremely dangerous. You know, a guy in Spokane got decapitated by some drill steel in a lathe, and people got hurt all the time. So it was just part of it. I'm nearly deaf because nobody wore ear protection. And if you probably took time to put ear protection on, you might get fired for wasting time. It's just the way it was, and people got hurt. Well, now here in Washington, you have to have guards on everything, and you couldn't have something with any open belts or something like my grinder over there, or not having wheel guards on a tool cutter grinder. But most shops have gone to carbide, and here's some carbide right there. That's about 5 pounds of used carbide. Rob gave me his old carbide, and I mixed it with mine. So what you can do with all this stuff is just simply braze it to something, and you got a cutting tool. But it's easy to buy those inserts, and they're fairly cheap. The standard ones are cheap, and I like using them. But when you start getting into special shapes and stuff like that, or high shear inserts for cutting without deflection, stuff gets pretty expensive. And that's why I have a tool and cutter grinder. And plus, I can basically get something done over a weekend. And as far as I know, this little band here in this county, Walla Walla County, and Asotin County or something, there's no guaranteed next day delivery. With many, it might have changed in the last couple of years. So it's always kind of handy to be able to, come up with something on the fly. And one of the things that I've always enjoyed about this work, being in the repair and stuff like that, is fixing equipment that's broken down and people are idle or a business just comes to a grinding halt. And I always made myself available on weekends for emergency, at a little extra charge, that is. But anyway, in today's world, and it's a new world here, my advice to get started on machining would be watching Blondie Hacks, because she goes through the very basic stuff that when you come down to it, the most complicated projects is just a series of the most basic machining operations. So that would be the best base, And I thought about this a lot, and I asked old Jim, the instructor out here at the community college, way back. I go, what's the best project that I could do to show potential employers or customers and stuff like that? And his suggestion is this, and it's the same as Blondie Hacks, and that is these steam engines. This thing's really dusty. It's been up on a shelf, and the little governor I got here, I need to oil it. See that? Look at this. Models are kind of cool, but you can't actually make them work like they're supposed to because the parts are too small. So this governor, the fly balls go out, and it just lifts this pin and lets some steam or whatever escape. I've yet to build a boiler for this thing, but these things run on air. And I built several of these things. Now, one of the things that these teach you is all of these little parts here, let's move it. All these little knuckles and stuff like that. These are oilers. Let's look at them, see? Little tiny cap there. Made all those. Now this was a kit of castings with plans. And the material. Get that little cap back on there, I don't want to lose it. But these things teach you mechanics at the same time. Now, on the plans for these things, they show the dimensions of the parts, but no clearances. So if you're making something like this, they'll show, well, the shaft might be 3/8 or something, then they'll show 3/8 hole through the bearings, but it's not going to work that way. You're going to have to give the bearings some clearance there. The shafts will rotate. So you get into Machinery's Handbook and look at clearances and fits and sizes, and it'll tell you running fits, sliding fits. So you can find all of the clearances on something like this. And alignment is kind of difficult. If you look at this, you see how the crank pin is. So you have to get all this stuff aligned for it to work, or it'll bind. See? So these being connected by one pin here, you're going to have to shift it. It'll get pinched, it'll get spread, and you got to true that up. Like I true stuff up in the lathe, see? It's all related. Now, the one thing about getting started, like the Blondie Hacks, working with high-speed steel, that'll come full circle if you start working on carbide, start making your own carbide tools, which I'm really into. The one reason is it's sustainable and not expensive, and I'm not doing any kind of production. So I'll continue buying the CNMG inserts to blast stuff off and cut off inserts and stuff like that. But when it comes to shaping stuff or precision finishes, I'm gonna use brazed carbide and get a high shear tool with minimal deflection. And I'm going to show something on that. I think I'll go ahead and do that. And it relates to that, but I was talking to a carbide insert engineer some years ago, and he goes, yes, that's true, but it's more complicated. And it is with carbide inserts. They're actually remarkable engineering. But I can show you some basic things that maybe you don't know. One thing, and it could be kind of a light bulb going off in your head moment. It was for me when I was first showing this. So I'm going to show that right now just for fun. Okay, I'm going to show something real simple about the basic cutter. We'll call that a basic cutter there. Just a standard brazed carbide AR type, micro 100 of course. Okay, so let's say this, your work, looking at it from the end. Oh, this angle, I don't know how well I can draw a circle. And I want to kind of tuck it in there a little bit. Okay, so your cutting is not exactly on center, so bear with me, okay? I'll move it up here. So, when you're cutting something, there's going to be more metal. It's turning this way, turning that way. So when you're cutting something, actual cutting, there's more metal above than below, right? Because you've already cut it on below. So it's coming around like that way, getting cut again. So you got the cutting tool in here. All right. Got clearance, nose clearance. So what is actually happening is it's not cutting here just yet. It's cracking the metal, a crack. And that crack must go to the outside of the work. Now, and what happens then is it comes around, it cracks the metal away, and then it shears it, okay? Now, if you don't have enough rake, the crack goes inside, and then as it comes back around, it's not shearing it, and that's when you have a rough finish. This is kind of exaggerated, and I hope I'm making sense here. If you don't have enough rake on the top this way, or if it's negative that you could use on brass or something soft, it'll put the, on steel anyway, it'll cause the crack, that the tool splitting, see? That's like a wedge. So that splits the metal and causes a crack. And you want that crack working to the outside, so when it comes back around, when it goes further, comes further like this, see? The tool come further, and that's when it starts shearing. And if you don't have enough rake, the crack goes towards the inside, and then when the tool reaches that point, see, it's not shearing, and then you have a rough finish. Think about that. Now, I want to say again that carbide inserts, let me grab one, are complex. And I think they basically do the same thing, but I frustrated a carbide insert engineer by showing this. He's going, it's much more complicated than that. And it is, you know, with these inserts and stuff. They got shock waves, they got everything, they got computers and brains on it and everything. Now, this is old time stuff like high-speed steel, and it's more simple. And see, I can control the finish by that top rake, okay? And I'll add a little bit more mystery to it. If you're getting a bad finish, you can increase the speed, and that forces the crack more towards the surface, just to complicate it. Okay, just something to think about. Okay. It's really nice to start making parts on these machines after spending so much time working on the machines themselves. These were in pretty bad condition when I got them. The Axelson here was just really filthy and needed a bunch of stuff. I think I have over 200 hours in it, but I like doing it, you know. And one of the things that's kind of cool about this machine is it's more versatile than I ever thought it would be. I'm able to do small parts on it and easily hit a 0.5 tolerances with it, and that's just great. I think I'm the only one on the internet that removed a digital readout on a lathe and put a travel dial on there. I use for if I want to, you know, these dials on this thing, they're like 400 thousandths per revolution off the work. So they put this little dial indicator on there. See, that's a 10th reading one, and that's all I need. The digital readout found a good home. I traded it to Rob for this collet setup here, which is working really good. It's just a fantastic thing. Here's some of his one of his surplus ejector pins. They're really accurate, so I put this thing on and I test it to make sure it's running true, and it does. So this is really a nice addition, and this size lathe is pretty good for changing chucks, as long as it's not the chucks aren't too big. And I've got a 6-inch 3-jaw, a 6-inch 6-jaw, 8-inch 3-jaw, and an 8-inch 4-jaw. Then down here there's a 12-inch 4-jaw and a 12-inch 3-jaw. I can chuck things up pretty good with this thing. But these older machines work out really good if you can find one in reasonable condition. And this one it turned out to be pretty good. Now, one of the things I think is kind of funny is you can do something on YouTube, and you can make people really mad. And one of the things is this tool grinding seems to be some territory that some people have staked out, but they don't make videos. All they want to do is criticize. One of the things I found working on different things, you do steam engines and working on old machines and stuff, is woodworking. And one of the things you learn pretty darn quick in woodworking is how to sharpen things. And I'm talking about if you're doing a bit of hand work and stuff like that. And it starts with being able to sharpen a pocket knife. I'm not kidding you. That's a good thing to be able to start with when you're doing work like that. But anyway, if you can't sharpen a chisel or something like that, it's not going to work with beams. And one of the things you learn is you grind against the edge. And the common way to sharpen milling cutters is to grind away from the edge and put the tooth rest on the face and then grind away from it. Leaves a burr you got to take off, stuff like that. Leaves a crappy edge when it comes down to it. But it might be good enough for most applications, but not mine. No, I want stuff sharp. And one of the things I should point out is if you're trying to mill on something like that jig bore that's holding my cup of coffee right now, the spindle in it is real stiff. And so you have to change the angle of the cutter a little bit, make it a little bit more acute so it's slicing a little bit more, or the machine will hammer and it'll tell you it doesn't like it. So if you're going to mill on a more jig bore, the cutting angles have to be right on the cutter, and plus it has to be just very, very sharp. So I sharpened this cutter here, and it really made one guy mad. He had to ban him. And I'm going to tell you this: I do not sharpen cutters commercially. I sharpen cutters for me, and I'm going to do it the best way. I'm not going to do it your way, their way. I'm going to do it my way. Okay? Because this is what I do. And all I can do is show you what I do. And if you don't like it, go somewhere else. Okay. That aside, I cut the square on that bolt here on my beautiful mount that matches. Oh, it's so nice. Matches the machine. It actually looks like a real Axelson attachment. So anyway, I can switch this thing up to making smaller parts pretty quick. This tailstock turret is limited to drilling in the steel with about a 3/8 drill bit, where it starts flexing. So it's kind of a bench lathe kind of thing, you know. But it's just real handy just to kick out some stuff. So this is just a great addition, the collet closer, and the tailstock turret. And you can also get away with a tailstock turret on the Axelson with that massive tailstock. I mean, this tailstock is just about easily 3 times the weight of a Morisiki tailstock. You know, this thing's heavy. Okay, I thought I'd point that out. So I will show this old milling machine over here, cutting something with some people think an improperly ground cut. Okay.